Okay, welcome back. This video is a continuation of the previous one because it got a bit too long. So we're going to dive straight in and look at an example of studying homomorphisms between Z12 and Z30, making use of what we know about the properties of homomorphisms from the previous couple of videos. Alright, so what we're going to do is we're going to look at all the possible homomorphisms between Z12 and Z30 that we can construct. So we'll say let phi be a homomorphism with an H from Z12 to Z30. Okay, so just like when we did a similar example with automorphisms, phi of n is going to be phi of 1 plus 1 up to n times, which is going to be n times phi of 1 because phi is operation preserving. So the entire homomorphism is determined by what phi of 1 is. When we'll call that A. Alright, so we just need to know what possibilities we have for A. Once we've got that, we get the entire homomorphism. So what do we know about A? Well, first off, A, where is A? So we're going from Z12, let's just draw a little diagram again, to Z30, which is bigger. So we've got 1 in here, and we know that maps to A over here through phi. Okay, what else do we know? We know Z12 is generated by 1. Okay, it's not that entity, don't get confused between multiplication. And let's see what corresponding thing happens here. Alright, so first off, we know A is a member of Z30. Right, so the order of A must divide 30, okay, because by Lagrange's theorem. Because orders of elements always divide orders of groups. But we also know from our homomorphism properties that the order of A divides the order of 1, which is 12 in Z12. Alright, so we actually got two restrictions on the order of A. It has to divide 30 and it has also to divide 12. Okay, so there aren't so many possibilities over here. So the order of A is therefore, let's see what's possible. Let's look at the divisors of 12 and only keep the ones that are also divisors of 30. So 1 is a divisor of 12 and 30, great. 2 is a divisor of 12 and 30. 3 is a divisor of 12 and 30. 4 is a divisor of 12, but not 30, so we have to skip that one out. 6 is a divisor of 12 and 30, and in fact, that's it. Alright, so we don't have that many possibilities for the order of A, which means A itself, what possibilities do we have? Well, order 1, there aren't that many of those, just the identity. A being order 2, there's just 15. Elements of order 3, well, there are 2 of those, there's 10 and 20. And elements of order 6, there are 2 of those as well, 5 and 25. Alright, so we've only got 6 possible options for the image of 1, which is A. So A can only be 0, 15, 10, 25, or 25. Alright, it turns out, and you can verify this, we'll look at one of them in a minute. Each one of these is well defined. So when I'm talking about each one of the 6 possible homomorphisms is well defined and operation preserving. we'll just look at 5. 5n equals 5n. And obviously we're working mod 30. Okay, so we'll just look at this one, but the same kind of ideas are going to apply to all of these. So let's look at practice some of our things. So kernel, what is the kernel of this function of this homomorphism? So note, the kernel of phi is the set of all things in Z12 such that 5 times it equals 0, the identity mod 30. Okay, so what possibilities do we have? Well, the kernel, clearly 0 is going to be in the kernel. What other things can 5 times the item be a multiple of 30? Clearly 6. 5 6 is a 30, which is 0 mod 30. We can't get, can get to 12 is not in Z12, so that's all we've got in our kernel. There is 2 options. Okay, so that means our Z12 is going to be partitioned into cosets of the kernel. So let's see if we can illustrate this. Let's give it a go. Z12 is going to, let's draw it this way up. Okay, so these are going to be my cosets here. So we've got 0, 6 is 1. In fact, let's leave out the horizontal line. 1, 7, these are the cosets of the kernel. 2, 8. 3, 9. 4, 10. And 5, 11. These are the various cosets of our kernel. And these are going to map to particular elements. So this one gets mapped to 0. This one gets mapped to 5. I'm just taking 5 times it, mod 30. 5 7s are 35, which is also 5. You can see this is going to work. 5 8s are 40, which gives me 10, so is 5 times 2. This one gives me 15. This one gives me 20. And this one will give me 25. Alright, so this particular homomorphism maps these things onto this subset of Z30. Alright, so it is nowhere near onto. Most things in Z30 are not hit by our homomorphism. We're only mapping into those 6 possible options. Phi is not onto. It couldn't be anyway, because there are 30 things in Z30 and only 12 things in Z12, but our homomorphism only touches 6 elements of Z30. Alright, let's just check the operation preserving part of it. Note that A plus B mod 12 or equals, let's try that again. If I take A plus B mod 12, then that's just actual A plus B plus or minus some integer multiple of 12. Okay, for some k. Alright, so let's just check the operation preserving part. So phi of A plus B mod 12 equals 5 A plus B plus 12k mod 30, which in turn equals 5A plus 5B plus 60k mod 30 is just 0. So it's just going to be 5A plus 5B mod 30, which equals phi of A plus phi of B mod 30. And this helps to explain why if we choose an A other than one 0, 5, 10, 15, 20, 25, that will get something bad. So why is phi of n equals 2n not a homomorphism? Well, let's just do it by example. Let's do phi of 7 plus 8 mod 12. Right, equals, if we do the addition before phi, we get 3. Phi of 3, which equals 6 mod 30. But if we do this after phi of 7 plus 8 plus phi of 8 equals 14 plus 16 equals 0 mod 30, which is not equal to phi of 7 plus 8 mod 30 mod 12 in there. Okay, so you can see it breaks is not operation preserving. If we have an A other than the ones from our list, you can see how it falls over. We get different results depending on whether we add 7 and 8 before phi, or whether we add phi of 7 and phi of 8 together. We get two different answers. Okay, so that's the method by which we can use some of our properties to figure out all the possible homomorphisms between two integer groups like these ones. Right, so we'll leave that there and pick it up in the next video. So have a good one.